we present a generative probabilistic model that can be used to synthesize new shapes from complex domains demonstrated by a set of examples. Given a limited number of compatibly segmented shapes from a domain, such as construction vehicles, our method automatically learns a probabilistic model that represents the structural variability within the domain. The key idea in the design of the model is to relate probabilistic relationships between geometric and semantic properties of shape components to learned latent causes of structural variability. Here are some learned styles of construction vehicles, and here are some learned styles of their components. Given the trained model, plausible new shapes from the domain can be synthesized automatically. In the picture below, the blue shapes are synthesized by our model from the input shapes in green. Our model can be used to amplify an existing shape database. Here is a set of 42 shapes used as input. Our model automatically synthesized 199 new shapes distinct from the input shapes and from each other. These are shown in blue. We applied our method to several other datasets. For example, 88 input chairs were used to synthesize 870 new chairs. 22 construction vehicles were used to synthesize 253 new vehicles. 69 creatures were used to synthesize 563 new creatures. 100 airplanes were used to synthesize 1,267 new airplanes. Our model can also enable interactive shape synthesis interfaces that allow rapid creation of plausible shapes subject to high-level constraints. Here we demonstrate the interface with a model trained on ships. The top tab on the left shows automatically discovered shape styles, which correspond to modern warships, sailing ships, cargo ships, old-style frigates, and patrol vessels. The tab below shows categories of components associated with each shape style. Here are components of warships. Here are components of sailing ships. Here are components of cargo ships. The two tabs below show automatically discovered styles of components and individual components from these styles. The user can drag and drop preferred shape styles, component categories, component styles, and individual components into the constraint specification area on the right of the screen. The model then synthesizes ships subject to the specified constraints. Here is an example of a synthesized ship. We now demonstrate the interface with a model trained on creatures. The model automatically learns various styles of animals, such as dogs, cats, reptiles, dinosaurs, frogs, rodents, and so on. Here are shapes synthesized for the rodent style. And here are shapes synthesized for the frog style. Now, we show an example where the user specifies several constraints for synthesizing novel dinosaurs. Here are the results, and here is an example of a synthesized dinosaur. We evaluated the performance of the presented model, both quantitatively and qualitatively. We compared the model to several alternatives using holdout validation to measure generalization performance. In this figure, dark blue bars show the performance of our model. Lower bars indicate better performance. Our model outperforms other alternatives for all datasets. We also evaluated the performance of our model qualitatively by conducting an informal perceptual evaluation with 107 volunteers. Each participant was asked to complete a web-based survey in which they compared the plausibility of pairs of shapes. In this example, the shape on the left was synthesized by the prior probabilistic model described by Chaudhuri et al., and the shape on the right was synthesized by our model. Here are the results from the evaluation. Shapes synthesized by our model were seen as significantly more plausible than the shapes generated by the model of Chaudhuri et al. We conclude by showing the airplanes synthesized by our model, in blue, along with the training shapes, in green. Each synthesized shape is placed near its most similar training shape. Our model amplified the database by an order of magnitude, creating plausible new airplanes of various styles.